Hello. So today we're going to tackle something under simple curves. So these offsets are from the tangent. So I'm going to educate you something a little bit on the offsets from the tangent. So we are going to get our formulas and how they are gotten. So there is a lecturer Tibet Sidak, Gathigira Steven. So let's go ahead. So here we have offsets from the tangent. So offsets from the tangent can be calculated and as also used to set the required curve. The offsets can be either radial or perpendicular to the tangents. So we have two methods or two ways in which we can identify the offsets from the tangent. So the first is the radial. So and in the radial, so the center of the circle, so that is 0, here is inaccessible from the points of the tangent. This method is very much possible. So this is the method that is used when the center of the curve O is inaccessible. So we'll go directly. So let B be the point at distance x from T1, and now it is required to find the radial of the ordinate x, which is equals to DE, so that the point C on the curve can be located. So the distance x from T, as you can observe it, so this is the distance x from T. Then the distance DE, that's represented by the offset x. So here we are forming something so like a right angle triangle, and any tangent that bisects or which is is perpendicular on a curve. So any tangent that circumscribe that something like that. So here we have the radius. So any radius to any point of the curve which the tangent points meet is 90 degrees. So here we have a right angle triangle that is formed. So this is a right angle triangle that we can see there. So here we get a right angle. So this OTD. So this is the right angle found here. So O to T1 to D. This is the right angle that is formed here in our equation. So from that right angle triangle, so the distance OD squared is the same as distance O to T1 squared plus T1D squared. So this distance, so the length OT, T1 to D, then D to O. So by squaring either of the two, it gives you the answer of the other. So that formula is just simple. So when you square the opposite and the adjacent, it gives you the hypotenuse. So that formula is found in our mathematics. So we can say here the distance. So the square root of this and the square root of this, it will give you your answer for the hypotenuse. So that's where we are saying, so the square root of either of them will give you our square of either the answer. So an example we can say, so this concept I like much to make sure that I can prove it. So let's say here we have, let me use that 3 4 5 method. So here we have 4 meters, here we have 3 meters. So I want to prove the 5 meter that is found on the 3 4 5 method of setting a house, setting out. So let's go. So here we have 4 squared plus 3 squared. But the use of a calculator, this will be 16 plus 9, giving you a total of 25. So that proves that 4 squared plus 3 squared is equals to 5 squared. So this is the concept that we are using in our calculation here. So that's just a simple concept. So that is the concept that we are using in order for us to find the distance that we are looking for in our diagram there. So let's go ahead. So OD squared plus OT1 squared. So this OD squared is equals to OT1 squared plus T1D squared. So these are the distance on the right angle there. Yeah. So then distance OD squared here on our diagram. So the distance OD squared. So that will be R, the distance from here O to where our is. So that will be R plus offset x. So this is the distance that will be represented by distance DO. So the distance from here to here, that will be R, which is known, plus the offset x. In this case, that is what we are looking for. So we need to compare those data in order for us to get that. So we square that, that is placed on the bracket. Then distance O to T1 squared, back again here on the, so O to T, these R, so you can see that from here to T1, that is R, so that is R squared here, then plus distance T1 to D, that is X, that was given the on our figure. So this distance is X. So we are translating, so we are looking for our solutions. So that will be x squared. So here we have a full formula. So these were represented by what was found on the figure. So these were only the distance. This was what were representing the distance. So by simplification, so here we'll square and here we'll square. So by squaring here, it will remove the, so by having a square root here, it will remove the square. Then here we have the square root again. So our final answer becomes, so offset x plus r is equals to the square root of r squared plus x squared. So a lot of people like to ask where we don't simplify this. So if we simplify it, our answer cannot be r plus x, so that's wrong. So we again, so the r is brought on the other side, so offset x is equals to square root of r squared plus x squared minus r. So this is the final formula that we have on our equation there. So an approximate expression of OX may be obtained as explained. So I have explained it here. So this is the final formula that is used in calculating offsets from the tangents. So this is the first method, the radial offsets. So that's the formula of calculating offsets from the tangent using the radial method. Then number 2, here we have the perpendicular offsets. So if the center of a circle is not visible, perpendicular offsets from the tangent can be located on the curve. So where the center is not so much visible, we can have a perpendicular of the offset obtained there. So these are representation of that diagram. So remember that. So this diagram is a little bit different. The other we had this distance to this distance having, so that was a straight line, and in this case that is not a straight line. So the perpendicular offsets and that is offset of x can be calculated by given here. So when you drop a perpendicular e to E1 and also from O to T, so here is that perpendicular. So our perpendicular was dropped here, so we dropped the perpendicular with the same and we got this was where our perpendicular was dropped. from that. So by dropping the perpendicular, then we have our distance of the offset x will be equal to DE, and that is equal to T1 E1. So offset x is equals to DE. There we have it. So this distance, and because we have dropped a perpendicular, that is the same here. So this distance and this distance are equal, because the perpendicular is something that is parallel to that line there. And if you have dropped a perpendicular, so you can remember, so when the line bisect the radius, so the tangent, there we have a 90 degrees, so you remember that. So the 90 degrees also is applied on our E1 there. Make sure you remember that. That's an important point to consider there. So this offset x is the same as this, and then now we need to find the value of offset x from our diagram. So by going back to the diagram here, so in order for us to get this offset x, so offset x we have already have a similarity of the same here. So offset x is equals to the distance t1 e1. So this is the distance, and in order for us to find the offset x here, so from t1 to the center of the circle, that is the radius. So in order for me to find the remaining distance here, that means I'll have to subtract the offset. So the distance of t1 to e, that will be subtracted. So in order for me to get the distance, so because this is the triangle that I'm going to have the similarity, that's where I need my calculation to be. So I'll need to find the distance O to E1, and that distance will be R, which is the radius, the total distance minus the offset. So the offset is the distance between T1 to E1, and that is what has been done here. So again, so here we have, so we subtract, they have done that, so by subtracting that we'll get our distance that is calculated there. So by subtracting that, let me get there. So by subtracting, so distance of x, there we have already gotten, so OE, let me do it here, it's much simple. So the distance OE, so here again we'll have O E1 squared plus the distance E1 to E, and that distance is x, as you can observe here. So that will be E1 E squared is equals to the hypotenuse. So the distance O to E, so that will be OE squared, just like what we have done earlier on our equations here. So let me, so in this question we have already been given the answer. Let me show you how they got that answer. So by squaring that, so and again, so OE1, so O E1, that will be R minus the offset. I've shown you how you have gotten that. So R is the distance from O to T1, then I'll subtract the distance T1 to E. So by subtracting that, this distance become R minus offset X squared, then plus E1 E squared, that is X squared, is equals to OE, that is R squared. So this is the equation that we are looking at. So by having shifted, so that will be R minus offset X squared is equals to, I move the x to the other side, that will be r squared minus x squared. Let me change that in order for it to be visible. So by doing that, here we have the square root of that and the square root of that. So by doing that, here the square cancel these because that is in bracket. So that will be r minus of 6x is equals to the square root of r squared minus x squared. Then by shifting this, so this is a negative. So this will be negative of the offset x will be minus r squared x squared. Then this r we have here a positive. So in order for us to eliminate this negative, we'll divide here by negative, and also we'll divide all this by a negative. That's why our final formula will be this. So by dividing that negative there, so here will remain with offset x is equals to, so this will be here value. So by so here we will have a negative, so that will be r. We can simply do this, so that will be r here, that will be r minus what we have here. So because we have divided everything here with a negative, so the negative will be here, so minus r into r, the square root of r squared minus so minus x squared, just like what has been done here. So this is the final formula. So they didn't show you how to do that, but I have shown you how you can do that here. So this is just a simple representation. So these offsets of the tangents by radial offsets, and again here by perpendicular offsets. So that's how the formula of offsets from the tangent is gotten. I hope that has been informative. So I'll again do that on other. So watch the next videos. They'll show you how to do other simple circular curves calculations and how to derive them. So that will be all. Thank you. Hello. So